Download this code from codegive.com, link in the description below. OK, let's dive into creating a node.js application that interacts with a Microsoft SQL Server, MSSQL, backend for CRUD, create, read, update, delete, operations. I'll provide a detailed tutorial with code examples, explanations, and best practices. Prerequisites *. 1. Node.js and npm, Node Package Manager. Make sure you have Node.js installed on your system. npm comes bundled with Node.js. You can download it from https://nodejs.org/ https://nodejs.org. Verify installation by running node v and npm v in your terminal. 2. Microsoft SQL Server, MSSQL. You'll need access to an MSSQL server. This could be a local instance you install, example SQL Server Express, a cloud-based Azure SQL database, or an existing MSSQL server on your network. You'll need the connection details, server address, database name, username, password. 3. Azure Data Studio or SQL Server Management Studio, SSMS. These tools are helpful for managing your SQL Server instance, creating databases, and running queries. Download Azure Data Studio from https://learn.microsoft.com/enus/sql/Azure Data Studio /download Azure Data Studio, https://learn.microsoft.com/n-us/sequel/azure-data-studio, or SSMS from https://learn.microsoft.com/enus/sequel/SSMS/download SQL Server Management Studio SSMS, view equals SQL Server ver 16, https://learn.microsoft.com/n-us/sequel/SSMS/download-SQL-server-management-studio-SSMS ? View =SQL-server-ver 16. Step 1. Project Setup. 1. Create a project directory *. Create a new directory for your node.js project. Open your terminal or command prompt and navigate to the directory where you want to create the project. 2. Initialize the project *. Use npm init to create a package.json file. This file will manage your project's dependencies and metadata. 3. Install dependencies *. Install the necessary packages. Tedious, this is a pure JavaScript MSSQL driver. It is a popular and reliable choice for connecting to MSSQL from node.js. Express, a minimal and flexible node.js web application framework. We'll use it to create our API. Body parser, middleware to parse incoming request bodies in a middleware before your handlers, available under the req body property. .dotenv, to manage sensitive information like database credentials using environment variables. .cores, provides express middleware to enable cores, cross-origin resource sharing, with various options. Step 2. Create the database table, SQL Server. 1. Connect to your SQL Server * using Azure Data Studio or SSMS, connect to your SQL Server instance. 2. Create a database, if you don't have one. 3. Create a table *. Let's create a simple products table for our CRUD operations. Step 3. Set up environment variables, .env file. 1. Create a .env file * in your project's root directory, create a file named .env. This file will store your database credentials. Never commit this file to a public repository. 2. Add your database credentials *. Replace your _server _address, node MSSQL DB, your _username, and your _password with your actual SQL Server connection details. Step 4. Create the node.js application, index.js. 1. Create index.js *. Create a file named index.js in your project's root directory. This will be the main entry point of your application. 2. Import modules and set up express *. 3. Configure the database connection *. We load the environment variables using .env. The config object contains the database connection settings. Encrypt, true is recommended when connecting to Azure SQL database. For local development, you might need Trust Server Certificate, true. Important * in a production environment, obtain a valid SSL certificate for your SQL Server instance and set Trust Server Certificate, false. The connect to database function establishes the connection using the configurations from the .env file. The application listens after successfully connecting to the database, ensuring that the server starts only after the database connection is established. 4. CRUD operations, API endpoints. 5. Helper functions for database interactions *. We define helper functions for each CRUD operation: get all products, get product by ID, create product, update product, and delete product. These functions use the execute query function to execute SQL queries. Parameterization *. We use parameterized queries to prevent SQL injection vulnerabilities. The @parameter _name syntax in the SQL query is replaced with the actual values from the params array. We also specify the data type of each parameter using tedious.varchar, tedious.int, etc. Make sure to import tedious with const tedious equals require, tedious. Error handling is included in each function. Step 5. Run the application. 1. Start the server * in your terminal, navigate to the project directory and run. You should see server is running on port 3000, or your configured port, in the console, along with connected to MSSQL server. Step 6. Test the API. You can use tools like Postman, Insomnia, or curl to test your API endpoints. Here are some examples. Get all products *. Get a product by ID, replace one with an actual ID. Post, create, a new product *. Put, update, an existing product, replace one with an actual ID. Delete a product, replace one with an actual ID. Complete index.js code *. Important considerations and best practices *. Error handling * Implement robust error handling in your application. Log errors to a file or a monitoring system. Return meaningful error messages to the client. Security *. SQL injection * Always use parameterized queries to prevent SQL injection attacks. Authentication and authorization * Implement proper authentication and authorization to protect your API endpoints. Use middleware to verify user credentials and roles. Data validation * Validate user input to prevent invalid data from being stored in the database. HTTPS * Use HTTPS to encrypt communication between the client and the server, especially when transmitting sensitive data like passwords. Connection pooling * Consider using a connection pool to reuse database connections and improve performance. The Tedious library supports connection pooling. The example above attempts to implement a basic connection persistence, but a dedicated connection pool library might be better for production. Asynchronous operations use async/await, as demonstrated, to handle asynchronous database operations in a clean and readable way. Logging implement logging to track API requests, database queries, and errors. This helps with debugging and monitoring. Environment variables store sensitive information like database credentials in environment variables. Do not hard code them in your application. Code structure organize your code into modules for better maintainability. Separate the data access layer, database interactions, from the business logic layer, API endpoints. Transactions for operations that involve multiple database updates, use transactions to ensure atomicity, all changes are applied or none are. Prepared statements for frequently executed queries, consider using prepared statements to improve performance. Connection resiliency implement retry logic to handle transient network errors when connecting to the database. This comprehensive tutorial provides a solid foundation for building a node.js application that interacts with a Microsoft SQL Server database using CRUD operations. Remember to adapt the code to your specific requirements and follow best practices for security, performance, and maintainability. Remember to install the necessary dependencies via npm install before running the application. Good luck.